Welcome back to Multisim 14.2 tutorial part 4. In this video, I'll show you analysis of a common emitter transistor. I have chosen R1 value 52 kiloohms, R2 4.7 kiloohms. There's a ground connection, but the only thing missing is voltage source. So let's go to this power sources. If you go to power sources, you can see VCC. These are dedicated sources for transistor. So I connect here and let's change this voltage. I like to keep it 10 volts. So our VCC is 10 volt here. We have to see where the biasing is. So if there is any single instrument or single place that we like to measure voltage or current, that should be collector emitter voltage in this circuit. So I like to use a probe, voltage probe. So let's put a voltage probe here. And we can change the parameters. We don't need all those parameters. We can customize it, make all no, and only VDC yes. That's okay. So we have VDC here, and so let's start with this first. And if we simulate, so I got 5.3 volts. So as you can imagine, this is 10 volt VCC and almost half of VCC. That means the operating point is somewhere in the middle of the load line, and this circuit is certainly operating in active region. So let's measure currents as well. Okay, so for currents, we will do the same thing. We'll customize it or make everything no, and just for IDC, yes, because we want to measure IDC. And let's put another current probe at the base. Do the same thing. No to all, but yes to IDC. So we're measuring just IDC. And now simulate. So we have 5.3 volts, 4.7 milliampere, which gives here 4.7 volts drop across R3 or RC, which could be. Then we have 28.6 microampere base current. So if we divide these two, we'll get about 165, which is the beta value for this transistor, and which is correct. So for your pre-lab and other calculations, just making this simple circuit, you can determine the base beta of this transistor, although this value is given in transistor datasheet. So next we'll see the effect of R2. In order to do that, let's stop simulation. Let's remove this probes, right click and delete, right click and delete. These are gone. Now, to know the effect of R2, we will do parameter sweep. Now we are here, we have a whole bunch of different analysis. So we'll go to parameter sweep. So in this case, we can change the values of any parameter that has been used in this circuit. So our device type, not BJT, we are looking for a resistor because we want to change R2. Now in the resistor, we have 3 resistors, R1, R2, R3. So looking for R2, this one. And what we are trying to see, resistance, current, or temperature constant, temperature coefficient, power, etc. But we want to see the resistance effect here. We are done selection. So the R2 value should start from 0 and it should go up to 10 volts. And with an increment of, say, 10 ohms. A lot of data points, as you can see, 1001 data points. Make sure this graph is, it's up to you, but now I need linear. And make sure analysis sweep is not transient, but it must be DC operating point. Change there. And we are good here. So for the output, we are looking for V3. That is our output voltage. So add V3. We already had V1 there, remove V1. So that's our output. Now everything ready and run simulation. It's getting there. Okay, very nice. Thanks for watching.